Hi, Algebra students. I'm on your workbook page M1 193. So the practice number 1 gives you a table, and it's showing the percent of the U.S. population who did not receive needed dental care services due to cost. So I'm given the year, and I can see the years increasing 1999, and it stops recording at 2009. So as a quick reminder, an interpolation would be anything within those ranges. Any year from 1999 to 2009 would probably give a good prediction. However, 2020 is nowhere near this range. That would be an extrapolation. The year 1980 would be an extrapolation. So only data within these ranges would be good predictors. So as the years go on, I can kind of look at my percentages and see those are, here's one where it dips down, but for the most part, here's one where it stays the same. Every year, here's the dip down. It's a general increasing trend. It doesn't seem like it's a wildly, first it jumps way up and then drops way down. Like it seems like it kind of increases. So I think it is reasonable to think a linear regression equation could be a good model for this. Another way you can determine that is looking at the scatter plot. I know they don't ask that until part D, but that could be really helpful for this as well. So for part A, I honestly am just going to say yes as X increases, as my years increase. The percents, the Y values, mostly increase as well. And it's not like they suddenly jump. It's not like I'm going from 0.2% to suddenly jumped by 10% one year. It's mostly just jumping a couple tenths of a percent each year. So that's kind of a good answer for A. I don't really like the question A, so let's move on to B. Determine the linear regression equation for the data, and we got to interpret it in the context of the problem. So this is when you will need your calculator out. Now, unfortunately, the device I'm writing on doesn't have that calculator, so I'm just going to have to show you, how am I going to do this? I'm going to show you my calculator this way and hope we can clearly see what I'm trying to show you. So if you just turned your calculator on, you should already have this cleared out, but if not, there we go. Now it's cleared. I'm going to put in my years into my first list. It is my independent variable. Time will always be independent. And I am just hitting enter after I type in each year. I should have had this done before I started this video so you didn't have to watch this process. Then I'm going to type in my percents, hitting enter each time. And I can see both lists ended on the same value. If you ever have one list longer than the other, you forgot a value or added in an extra value, and that's a problem. So I'm going to push stat. I'm going to scroll to calculate, and then I'm going to go to the fourth option, which will calculate my linear regression equation. I'm going to hit enter all kinds of times until it calculates it. My diagnostic is on, so you could see R squared and R. I'll go back through how to turn that on when we get to part C. But either way, what I'm looking for right now are A and B, because I just want to write this equation. I want to put a number in for A, I want to put a number in for B, and here are those two numbers. So let me switch back to a writing on screen. Knock stuff over. Okay, so I'm going to write my regression equation is y equals, it doesn't give me rounding directions, I'm going to use thousandths, so tenths, hundredths. There's a 1 in the thousandths place, but the 8 makes it round up, the 8 that's after it. So that's my coefficient of x, that's my A term, plus my constant term, actually it's adding a negative, so I'm going to go ahead and say minus 1015.tenths, hundredths. There's a 3 in the thousandths place. The 6 after it makes it round up. So I think a lot of people are totally fine calculating this. It's really the interpretation that's very difficult and hard to get used to. What I always tell my students, whether it's my Algebra 1 students or my dual credit AP honors stats class, every slope can be thought of how much y is changing as x changes. That's why when we look at a scatter plot and we see, oh, hey, look, it's an increasing trend, you're describing, oh, my y's are going up every time I look to the right. You're describing slope, but we're just not kind of talking about it in the context of the problem. So the context of this problem, my y variables were the percents. And that's as x changes. My x variables were the years. So this number, my slope, my coefficient of x, is describing how much the percent changes every year. So I'm going to say the predicted percent, because this equation gives me predictions. And if I had more room, I'd talk about the predicted percent of U.S. population who did not receive dental care services due to cost. I'd write all that down. I'm not going to. The predicted percent increases because I see a positive slope. It's going uphill. It's increasing, let's see, 0.512%. It's going up 0.5% as y changes, as my years change. So each year, every 1 year, the percent seems to go up for the most part, or I'm predicting that it'll go up by 0.5%. That's your interpretation for slope. I always start out the same way. If you're in my class, you've seen that numerous times. It's change in y over change in x, then I plug in what y and x are. I start out talking about the slope the same each time. I also start out talking about my y-intercept the same time. Now, a lot of people think y-intercept is just where you start graphing. So you'd put a dot somewhere. The thing is, every y-intercept is actually a coordinate. Specifically, it's the coordinate that does not take you left or right, but would, in this case, go down by 1015. Numerically, you could think of it, if I have an input of 0, well, 0 times this number is 0, so this turns to 0. 0 minus that number is just this number. So if I have an input of 0, my output would be that second number, that negative number. So you can think of it visually, you could think of it putting in a 0, but either way, I'm just going to write down the coordinate, 0, negative 1,115.584. That's also the same way I always start these problems. And then I put it in context, just like I did here, where y is percent, x is years, same thing. If x is years, this is year 0, and this is percent, which is kind of nonsense. This is not only an extrapolation, you're getting a value that's not even possible. So I do need to interpret it still. So in the year 0, the equation predicts a percent that's negative 1,000. Oops. The equation predicts negative 1,115.584%. So it's okay if that doesn't have real life meaning. That's just how I'm going to write mine up, because that's what it means for this particular problem. I'm going to make a second video for C and D if those are the only questions you had, so you didn't have to watch the whole video, but I'm going to stop this one.